Okay, this is the Unit 7 test, and working in question number 1 here, it says to add and simplify completely, and looking at two rational expressions. Um, and of course, to add rational expressions, you have to have a common denominator. And when you inspect these denominators, we have x minus 2 and 2 minus x. And so hopefully it's noteworthy to you there that those two expressions are signed opposites in their denominators. X minus 2, that's a positive x and a negative 2, and you want to add it to an expression which has a denominator of 2, that's positive, minus x. And so in order to get a common denominator, it's a simple matter to multiply either the left-hand term or the right-hand term by a negative 1. And top and bottom, of course, so we're multiplying by a fraction of a value that is really 1. So we're not changing the value, say, of this right-hand expression. But when we do this multiplication, you see that on that right-hand term, we're now going to have a minus 5, and we're also, of course, going to have a negative 2, because minus 1 times that 2 is going to be a minus 2, and negative 1 times the x is going to be a positive x, and so I'll write that as x minus 2, and we of course have our common denominator, so they can now be added. Of course, all the while in the numerator, this plus 5 is actually now becoming a minus 5, because again we multiplied top and bottom by minus 1, and so 5 plus minus 5 in the numerator, this expression is going to become 0 over x minus 2. And so your final answer on that first question should have been 0. Right? Second question is an equation. It's of a quadratic type. And so probably what you'd want to do here is to get one side to 0. And I'll get the right-hand side to go to 0 by removing the 5t by the additive inverse to the left-hand member. And now I'll carry on and use some factoring. And the first step in factoring is to look for a common number and or letter. And of course we have a 2 that is common to both terms here. And when we divide each term by 2 by t, that's what you're doing when you're factoring. You should see that we're going to get 2t minus 5 when we do that. And then we'll use the concept that when you multiply a number times a number and your result is 0, then we know that one of those expressions would be a 0. So we get t equals 0 as one answer. And the other piece of this, the 2t minus 5 equals 0, that solves and gives us 2t equals 5 and gives us t equals 5 halves. Right? And so then from there, the way you insert that into your answer box is you put in the 0 in WebAssign, and then you put a comma, and then you put in your other answer, and you can enter it as a decimal or the improper fraction that we showed it as. So you could enter the 5 halves, say like that, or you could use 2 and 5/10 or whatever way you want to do that. Clean this up just a little bit before we move on to the next question. And that would be question number 3. So slide down the page just a little bit here. And this is an exercise to factor completely. And factoring was a bit of an issue for people when we were doing that unit, but it seemed to smooth out for almost everybody. And so on this one, you can do it by AC method. It's quadratic, so you could do it by AC method or split the middle or uh, other techniques that you might have hopefully remastered, reviewed, refreshed over the course of the summer. And so you should have a 2x and an x when you were all done. And then we're going to have a plus 4 with the x and going to have a minus 1 when everything is said and done. And so in some order, you would have entered 2x minus 1 and x plus 4. so those would be in some order the solution to that expression. Now again, remember the directions here were just to factor completely. And if you compare that to question number 2, where we were solving an equation, make sure you've grasped that idea. Here, our work was just a factor. We were working with only an expression. There was no equal sign. And so when we factor it, we'd stop at this point. Okay. Question number 4 comes from the um, trigonometry unit, which was unit 7. And we want the sine of 7 pi over 6. Now, it seemed as though most people were more comfortable changing these to degrees, and that's fine, but be aware that in the calculus, you'll only be seeing angles in radians. If you want to convert this to degrees, it turns out to be 210 degrees. And so they want the sine of 210 degrees. If we draw ourselves a little diagram, 210 degrees would have a terminal side in the third quadrant, right? 210 degrees would be about there. Um, this being the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? And then the reference angle, always measured to the horizontal, the reference angle for an angle that has a terminal side at 210 degrees is going to be a reference angle of 30 degrees, because the measurement from the horizontal, the 180 degrees, to the 210 is a difference of 30 degrees. So the sine of 210 degrees is going to be the same as the sine of 30 degrees, except you're in the third quadrant. And in the third quadrant, the value of the sine has to be negative. So negative sine 30 degrees would be what we'd be trying to evaluate. We want the exact value of that. So it's going to be negative, and the sine of 30 degrees is 1/2. And of course, you can do that using a reference triangle, or perhaps you've memorized the unit circle values, um, or any other technique that will get you those base values for those 0, 30, 45, 60, and 90-degree angles, um, would be what we'd be expecting when you come into the calculus. So the answer there for number 4 is -1/2. Cosine 11 pi over 6, we do this in a similar way. I'll convert it to a degree measure, and 11 pi over 6 corresponds to 330 degrees. Okay. Um, by the way, that conversion to go from radians to degrees, we multiply by 180. You multiply the argument, in this case 11 pi over 6, by 180, and you divide by pi. So what that's going to look like is 11 pi over 6 times 180 and divided by pi. Well, of course, the pi values are going to cancel out. 6 divides 180 30 times. And then 11 times 30 is where we're getting that 330 degrees from. So um, if you can work just in radians, that's great. But if you feel the need to convert it to degrees, that's acceptable as well. Now, just to give us a little rendering of this situation, 330 degrees starting in the initial side on the positive side of the x-axis. This would be 90 degrees, 180 degrees, 270 degrees, 330 degrees, going to be just short of one full rotation. So that would be 330 degrees. You always reference to the horizontal, and the horizontal is the 0 degrees, or 360 degrees as a full rotation. So your reference angle in here is 30 degrees. That tells us then that the cosine of 330 will be the same as the cosine of 30 degrees. And now in terms of quadrants, remember in the fourth quadrant, which is where the terminal side of our angle lies, cosine is positive. And so this value for cosine 330 degrees will be exactly the same as the cosine of 30. And then again, using whatever technique you're using, the cosine of 30 degrees is exactly the square root of 3 over 2. So that's question number 5, and hopefully you've gotten used this summer to the WebAssign uh, software, and you'll be comfortable with that as you approach the fall semester. Okay, so I'll clean this up, do just a couple more maybe in this video, and so there's 1 through 5, and we'll continue with 6. Um, 6 is an exponential equation, which was a few units ago. Uh, exponential equation with a base of 4, power 3x on there. And the other side of the equation has a base of 2. Okay, and so when doing an exponential equation, by that we just mean an equation where the variable is an exponent. We have two approaches. We have the log approach, and we have the common base approach, and it all is linked to are the base numbers exponentially connected. It can 2 to some power and this 4 be represented as 2 to some power? Well, of course it can. 4 is 2 squared. So we rewrite on the left the 4 as 2 squared, and then that thing is being raised to the 3x power. And that equals, on the right, 2 to the first power. Well, right here, this power being raised to a power, that is now going to be 2 to the 6x power equals 2 to the first. We now have the same base. They're both 2's. The expressions as wholes are equal. And so from this, we know that 6x has to equal 1. Consequently, x is equal to 1/6. And so in the answer space, a 1/6. All right. Um, Probably put one more into this video. This will be question number 7. I'll clean up the workspace here first, and then we'll move on to the inequality expression that they're giving us here. Uh, we have solve for all values of x, and of course this is an inequality. And one thing we said with inequalities is don't worry about the inequality. Treat it as if it's equality. And then, of course, because this is a rational expression, want to be mindful that you can't divide by 0. And so we want to be mindful that x cannot be -2. -2 would be excluded from the domain of this left-hand member, because if x was a -2, you'd have division by 0. All right. Now from there, the other concept here, you have a rational expression, you have a numerator and a denominator, and the only way a rational expression can be equal to 0 would be if the numerator was equal to 0. And so we write x squared minus 3x minus 4 equals 0. Right? If you have an a over a b, and that rational expression equals 0, the only way that can happen is if a is 0, and of course b is not 0. So from there, a little bit of factoring, and this is pretty elementary factoring, so it's going to be just x minus 4 and x plus 1 equals 0. We set each of those factors to 0, and we have x minus 4 equals 0, which gives us x equals 4. And we have x plus 1 equals 0, which gives us x equals minus 1. Now, from that point, all should be well. We want to put those numbers in numerical order. Be sure you get them in numerical order. And we also want to be remembering that we have this x not equaling -2 that needs to be expressed and needs to be dealt with. So I'm going to put -2. I'm going to map in -1 here, which would be to the right of -2. And then finally, I'm going to map in 4. Now, of course, there's no intended scale here. Obviously, -2 and -1 are closer together than, say, -1 and 4. Um, but we're just trying to produce some intervals here. Now, from here, in this case, all of these identified points will remain as open circles, right? Because it's a pure inequality. It's strictly greater than, okay? If it had been greater than or equal to, then we would have shaded in the -1 and we would have shaded in the 4. If there'd been a line underneath the inequality to include equality, then we would have included the -1 and we would have included the 4, but we still would have excluded the -2 because the -2 is excluded from the domain. X cannot be -2. Now, from here, it just comes down to a matter of testing some intervals. And in doing this, for instance, if X was a 5, right? If X was a 5, then clearly your denominator, 5 plus 2, would be a positive number, right? And in terms of the numerator, you'd have 25, minus 15 would be 10, minus 4 more would be 6. So your numerator would also be positive. A positive divided by a positive, will that be greater than 0? That's what you're asking. When you do this test, you go back to the original inequality to check and see if a number from that region works. And of course, the number 5 does work. So that region would get shaded. And we'd indicate that as such. Now, a number in between -1 and 4, perhaps a test number of 0. And 0, very easy to work with. 0 plus 2, that's going to be positive. But the numerator now, a 0, minus a 0, minus 4, your numerator is going to be a negative number. It's going to be, in particular, -4 when x is 0. So you have a negative number divided by a positive number, and that quotient is going to be, in totality, that quotient will be a negative. Can a negative number be greater than 0? That's a no. And so numbers from -1 to 4 do not work. Okay. Uh, Now, as we show this next interval, I'm going to clean things up just a little bit. Um, get rid of some of this stuff over here and try to make this very clear. I'm going to use x equals -1 and 5/10. Okay. Now, again, we're going to look at this ratio, and the question we're asking is it greater than 0? Obviously, in the denominator, if x is -1.5, -1.5 plus 2, that's going to be a positive, right? -1.5, and you add 2, you will end up above 0 in your denominator. Now, in the numerator, -1.5 squared is 2 1/4, and that is positive because a -1.5 times -1.5 is going to be a positive. -3 times -1.5 is positive 4.5. And so that gives me 6 and 3/4, right? 2 plus 4 is 6, and 25 hundredths plus 5/10 is going to give me 75 hundredths. And so obviously 6 3/4, 6 and 75 hundredths. And then only subtracting 4. So 6 3/4 minus 4, that is clearly also going to be positive. What's a positive divided by a positive? Is that greater than 0? That quotient, yes, will be a positive, so it will be greater than 0. And numbers in that region will work. Numbers in there will work. All right. Finally, I need a number less than -2. For instance, -3. And again, I'll go back here, and I'm not really worried about the actual value so much as I am the sign of the value. And so when x is negative 3 plus 2, that denominator is going to be negative. And when you look at your numerator, you're going to have negative 3 squared, which is going to be 9, and minus 3 times minus 3, which is also going to be 9. 9 and 9 will be 18, and 18 minus 4 will still be positive. It'll be a 14, but it'll be a positive. Now, what is the quotient of a positive and a negative? Well, that's negative. Is a negative number greater than 0? No. Numbers less than negative 2 will not work. Now, in terms of the virtual tools, right? Hopefully you got familiar with these, and everything should be well. In a Google Chrome browser or Firefox browser, everything should be well. Depending on the version, you can use Internet Explorer, but we don't recommend it. You'd use the virtual tools to put open circles at negative 2, negative 1, and 4. And then you pick up and grab the pencil and you shade, you just click in between any identified points, and it will shade the region as you may want. So you would click above the 4 somewhere, and it will shade it all the way down to the bubble that you made. And you click in between minus 2 and minus 1, and it will shade that portion of the graph. And so that's how the virtual tools work. Okay, so that concludes this video, and we'll see you in the second part of this.